Bale. What's going on? We're going to be taking a look at the dual drive today. I got two SSG circuits going into one coil, and we're going to see how they behave in regards to each other and how they perform. If anybody wants to give a guess as to what's going to happen here, you're more than welcome. We are going to be running these two SSGs on power supplies, and they're going to be charging these batteries individually. Well, at the same time, but one power supply goes to one battery. This circuit right here is on this side of the table. This battery, that power supply, and this circuit go into this coil. Then I have another power supply down over here, and it goes to this circuit, that battery, and the coil. And without any further ado, let's get it started up. Some water take. Right, here we go. Turn on both multimeters. Come on, man. It's not working. I didn't adjust anything out of place just now. Alright. And the meter says 1212. Awesome. See this one on this side, one with this SSG with gen mode is not going to charge at all. But the one on the other side, just like SSG with a primary and a charged battery, the battery on this side is charging. The battery on this side is not charging. The difference is here is that there's two separate SSGs that are going into the same coil, and only one side is charging. Just like SSG, like a single SSG with a single variant coil would be doing the same thing if you hooked it one up to the, except this one isn't spending. This one is just dormant for some reason. I've never figured out what the reason is, other than the way that it's wired, the way that the circuit is made. It's always going to do one or the other, even if there's two of them. Now if there was one, now if this one was hooked up to a different coil, would it work differently? I don't know. I don't think so. Currently we're only 3 volts in. I'm going to turn it up to 12. Now I've turned this SSG's power supply up to 12. 300 milliamps are being drawn right now. This is steadily going up. The battery on the right is steadily going up. The battery on the left is stagnant, not going up at all. Let's turn the other power supply up now. Alright, now this one's up to 300, 400 milliamps, and the previous power supply that was at 300 milliamps is now at 700 milliamps. So, through that coil, all the circuits are hooked together, all the batteries are hooked together, and all the power supplies are hooked together through the coil. And now now it's going up extremely fast. The battery is charging rather well now. This one will not go up, just to let everybody know, we're not waiting for this one to go up. This one will not go up. And I just find it all particularly strange that it chooses, both power supplies choose the same path to charge on. It's weird to me that even though this SSG is hooked to a different battery, it doesn't have any power coming to its output. That's what I'm thinking is happening. All the power is just choosing one output and not going through both of them. And the reason that's happening is because it's all wrapped up in one bobbin. So I'm going to take another coil.
Twin asks, what does this do?
Right now it just moves and it charges batteries, and it's basically just a battery charger at the moment. I'm going to turn it into a relay right now though. On that. Alright, so let's turn this off and swap out .
Someone's pumping the love button.
Nice. Thank you. Alright, here we go. Dislocating this. Let's see, we can either leave this trigger strand in or take it out. We're going to take it out, but it would work either way, I think. Well, no, it wouldn't. Never mind. Different setup. Gotta switch the trigger strings with this one. Alright, so we're gonna hook up another 20 gauge coil. Now they're working both 20 gauge. My son's out there having a blast. I think he's playing some sort of tag. And you can't diss me. I'm an okay guy. You can't diss on me. You can't BS me. I'm an okay guy. If I get upset, it's not for my health, I guarantee it.
It's not from up down.
Now, the difference between these two coils is 100 turns in length. This one is 100 turns longer than this one. And the trigger strand is 30 instead of 32. In my opinion, 30 is a lot easier to put in these holes than 32. Now, will it charge? Will this battery charge now? I wonder. I think it will. Alright, let's turn it on and find out. Yes, we are charging. With the two separate coils, we're both on a charge. Hey. There it goes. We just had to tighten up the resistance a little bit. Yes. Woo! They're both charging at the same rate now. I wonder, honestly, if I hook them up to the batteries now, will they charge? Like what, if I were to now run these SSGs on the batteries, do I hook up the power to the opposite battery that what the output is hooked up to? Is the question. Does it matter? Can it work at all? I don't know. We'll see. Yes, 1217, 1217. Woo! Well, it's stalled out. It's not charging right now. There it goes. Alright, so I guess to get a better view of how that's going to end up, I gotta get a reading off of the output. Without it being connected to the battery. So, what do? We're just going to do that. Nice. So we'll take this clip. This clip. Alright, it looks like currently, wow, at 3 volts we're putting out 9 DC volts. That doesn't seem right, does it? At 12, we're putting out 40 DC volts. Oh. But our light was way on. So we're going to stop doing that. Okay, it looks like we're generating enough, right? Okay, so put this back up. All right, so this is the part that always stresses me out because we get all the way to the point where we're about to hook it up and it starts sparking. So we're gonna take it slow. sounds all awfully wrong. Doesn't sound right at all. I haven't been able to hook this up to a battery all yesterday. See, look at how violently that goes down. That's not right. But let's see here. That's why I use these in the equation. These cap banks, because it prevents the energy from flying back into your system and making it not work. Just so we're not confused with DC flyback, which is important. Oh yeah. If anybody has an idea on how to make this work, if it doesn't, share it with me. But this is a relay based solely on position. There's no timing except for the positioning. That was bad. That was the wrong terminal. Okay, that wasn't good. So what I'm going to try and do now is hook them to the same terminal, because the opposite terminal did not work. You saw that, right? It did not work. So I'm going to put the cap bank in. That didn't work either. So this does not like, it's shorted out. It's shorting out every time. There's no other way to connect this. So I'm going to add the cap bank. All right. Boom, 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 boom. Oh no, we're gonna swap them though. That's right. We're gonna put this output on this cap bank over here. Alright, and then this. We'll go to this one over here. I don't think I've hooked it up this way before. This will be interesting to see what will happen. Now this one, now I should be able to connect the power without any sparks. Now another thing you could do is put a diode on the line there, but this is virtually a diode, but it's a lot more than that. But it's got diodes in it. It's got 4 full bridge rectifiers. And it doesn't like, let's see, I switched out transistors. I'm pretty sure it's not a transistor. Oh no. Coil won't stop moving. Might be the transistor. Yeah, it's moving all over the place. I don't know. I'm gonna have to glue it down. Might have to change that transistor or that circuit too. Yeah, there's something not right with that.
Got a comment said you jump started the flywheel.
Yeah. Yeah, I did. Shoot. There's just a small problem. I think there's a transistor issue. And that one, let's see, we'll plug this one in. See what happens. Well, it's not working very well with just one. Let's see if we plug in the other one. Yeah, well, I think I'm gonna hook back up to one coil. And I might hook up the SSG instead of the SSG with gen mode real quick. Alright. This out of here. This one back in. This time we're gonna hook up a pot and a resistor. So this is the pot. And this is the way that it is now. I'll show you the difference in the two circuits, but this is how you're supposed to set it up. You're supposed to set it up a pot and a resistor. And this one is 230 ohms. Should be good for a baseline. And if the pot ever burns out, this will be there to protect everything. So the pot and resistance is hooked up now.
Resistances.
Yeah, resistance.
Resistance.
Viva! Ah. Alright, so black one is gonna be now, should I put it all into one coil, or should I try with the other coil out here? I'm gonna try with the other coil. Because I think when you put them together, only one side will charge. Not sure why that is, but you want them both to charge. Both to be charging. They don't have to go up in value, but they have to be charging. What does that mean? That means that we're going to be spending from both of these batteries as well. And if we're spending more than we're charging, it's going to go down regardless. Okay? Is there such a thing as charging while it's spending? Yeah, it's got to be interval, but yes.
Interval.
Yeah. At least that's what this relay is all about, and it being interval. So you got 180 degree magnets on the rotor. So when it's lined up here with this coil is off. When it's lined up with this coil is off. So this is based on timing and proximity. But it's just based on, physical timing. There's no 555 or anything like that going on here. It's just boom, 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 like that. It works. Works well. Works at a really high frequency, so, there's no really better way to do it without, getting more advanced. This is, in my opinion, as simple as it gets. All you have to do is spin the wheel and have your magnets and electromagnets in the proper position, and you win. Now, I believe this is called the Bedini bounce. Go in your home. Too good for your home? Unlock. And as you can see, we're down to the nubs here, and I can't get it in the hole. That's not right. There's got to be something blocking or obstructing my path. Could be that I'm blind. I don't know. I'm not. I haven't been diagnosed blind, but I'm pretty sure that if I go to the eye doctor, they will diagnose me close to that.
Blind.
Blind, boy. Now at least you can't see what's coming to eat you. God, this sucks. Come on. We got it.
Yeah.
All right. Wow, that was terrible. Let's see what happens now. Something's not right. might be the way I set it up. Let's try removing the resistance that I put in there, the resistor. Might be backwards, you know, like. And I'll tell you what, man, some schematics, everything's backwards. The way it's supposed to be and the way it is, like whether or not you put the potentiometer first or second is really important. It seems like it wouldn't make a difference whether you put the resistor or the potentiometer first, right? No difference there.
Be subscribed.
Thanks, Pete. But you're gonna find out right now that's not true. So, I mean, if you're gonna draw a picture, draw it right. Whether you use a computer or not doesn't matter. If you're gonna draw a picture, draw it right. Alright, let's see what happens now. I could have put the trigger strand in backwards. I think I did do that. No, I didn't. God, this wire sucks, man. Especially when it's all the same color. Oh my God. And you're blind? Jeez. Give me a break. I don't know what's going on here. Alright, I'm gonna take the pot out now. Taking the pot out completely. Because I just reduced the pot to its minimal and the light was still on. So I don't know what's going on here. Oh, that must have been it, because the trigger strand wasn't in all the way. Alright, here we go. Then I gotta put that resistance back in. This wire is giving me a lot of trouble. Put the pot back in. Moving up a little bit. Right. What I don't understand is why I'm getting the light. Let me just make sure everything's hooked up right. Oh. That might make sense. It might make sense. I don't know. Doing these combo circuits, I found they commingle. See what we got. Yeah, no. Oh, no, no. What's the freaking issue here? Don't even know. I probably shouldn't be messing with this right now, but. Oh. No, it's still in there. One more idea. I shouldn't have to do this though.
That's what I'm talking about.
No, that's what I'm really upset about. Is that I shouldn't have to be doing this right now because I've run this like this 100 times before this and now it's not working.
Yeah, that's no bueno.
Alright. So I got one more brilliant idea, and that's going to be that we're going to run closed loop systems on both sides.
basically swapping the outputs back to their original position.
Okay.
Oh. Let's see what the problem is.
We got a solid connection there.
Isn't that awesome? They tell you can't do it this way, and it's the only way that it works.
That'll speed up, I think. So what we managed to do by doing this is make this the rate of descent, the rate of decline in the battery slow down. So it's funny how you run the output back into the same battery you're doing the input from, and it works. It doesn't work, it's not working spectacularly, but this is working. There's no sparks, there's no smoke, and it's working. Currently, this battery is being drawn from the most. Yeah, I don't know. It seems to be very weak. But it is definitely working. It's not going that fast, and it's still working. And the lights on the cap banks are a lot dimmer, so I know for a fact that the juice is flowing.
Views.
Nice. Awesome. I was running one of the everything going through the one coil, right? And then I did it on 2 series batteries, so 24 volts. And the input and the output could both connect to the same battery without a cap bank. Or not the same battery, but the same battery system without a cap bank. But like this, on individual batteries, they don't let it, it's just, no. And you'll notice that it's either going to go really slow. And there's nothing the resistors, potentiometers are going to do to fix this. I've already played with them both, all the way, either way, and it's not the resistance. Or the pots are broken, but I don't think so. There we go. See, it's spending voltage that way. There we go. Oh man, so what do I want to do? This is pretty slow and cumbersome. I think I'm going to take down I'll leave this side up. I'm going to take the other side down. we're just gonna run the SSG. We're gonna see what we can do with that. I believe our goal is to find out how long it takes. And I'm not doing anything where I need to swap manually. I don't do that. Well, I do it all the time. That's not what I mean. That's not what I'm building. I'm not building something that is going to have to be messed with. So the battery wall, not my thing. If you gotta swap any of that crap, it's not my thing. If you got an auto relay swapping it, then I'm all for it. But you need that relay set up or it's not what it's supposed to be. All this stuff is supposed to do it itself. Really what it's supposed to do. From the get-go, that's what it's supposed to do. You know, it's supposed to run itself, it's supposed to think for itself, it's supposed to do it itself. I'm not taking this side going. Okay. Oh yeah, let's try this though. These ones, Alright, let's get that big coil off there in the Embark SSG. Just plop it right over here on this table. Oh yeah, that transistor looks a little burnt. Like the center pin looks like it's toasted. It might not be, but it definitely looks that way. Right. Now, I don't know necessarily how this is gonna go. I think I need the cap bank, but we're gonna check it out. Yep, we need the cap bank. Okay. So we take this one and we put it here. And we take this one and we put it here. Now there's other ways to do it. You can take a diode. Where did it go? It's not cool. Let's put it right there. There it is. You take a diode like so, and you can direct the energy of the output to the correct place. Or you can just use a cap bank like this that has full bridge rectifiers in it. And since it's better to send, have the energy change chemical chemicals every once in a while. It's good to have to go through a couple caps. Alright, you can see how well that wheel is mag-left now. It's been spinning without power for a while. See, now there's no jolting. There's no jolting because it's not shorted out. It's not hooked to another battery. It's not going that fast though. They can be going faster for it being only for being 12 volts. It's like, wow, it's going slow. But it is moving. We currently have this power supply hooked up to the input and output of the SSG. It's going through this cat bank. I don't know if you can see the cat bank. That cat bank on the corner of the table. Right here. So we're looking at 1210. When it hits 12.9, we'll start counting how long it's going to take for it to deplete. I mean, but you know, if the power, what the output wasn't plugged into the battery as well, that would have been 1209 a long time ago. At least I know that. Running that coil, it would have been done a long time ago. I want to check and see how much power is coming off of this tri-filer strand. Since we're not using it, might as well see if there's any power coming off of it. something's not right, and it might be with the circuit. Might be with the connection, because there's no energy coming off of that trifilar strand.
No power.
Oh. I think it is the circuit, but not the way you might think. But this block right here seems to be having a lot of trouble. Because, yeah, things keep popping out of it. I haven't had any of this kind of trouble yet, so I know it's not me.
New problems.
No problemos. I'm pretty sure it's something I can solve simply. Let's turn the power off. And plug this back in. Oh my God. Can't believe I didn't see that.
It was right there in the middle of the vision phase.
Right in front of my frickin' eyeballs. Alright, now, let's try that one more time.
Open it.
Yeah, it's going down way too fast. So that pot is all the way opened up now. Oh my God, it's charging itself. Dude. This is unreal. I do smell something though. Let me smell it. No, it's alright. It's alright. It is charging itself. I don't believe this. Just 1/100th of a volt though. We'll see what happens. We gotta wait and see now. It's gotta. Yes! Yes, dude. Frickin' A. So this is definitely charging itself. Dude, that's awesome. That's freaking awesome. I thought just a few seconds ago that wasn't possible. So the proper connection is having the input and the output. There's a cap bank here. Both going into the same battery, the output going through the cap bank. That is cool. Closed loop system, ladies and gentlemen, charging itself for 2/100ths of a volt now. Finally, man, I've been messing with that for a while. Hell yeah. See, there's no speed on the wheel either, so I'm taking most of that as oscillation.
Have a big thing on it. Oh, no. Move them over.
What's the question?
Wait.
No.
Your Would you rather see experiments with power supply or batteries?
Both. Alright. Yes, this is charging itself. Going extremely slow. So, I don't know, there's some idea that if it goes faster, it'll charge more. I've had it going really fast and have it not charge at all. But if you were watching that, that went up one, yes?
What would you say the charging rate is?
Slow, very slow.
0.01 volt per.
Well, if it goes up again, we'll be able to know from. Well, I said I was going to do that at 1209 to 1210. I'd say it's probably about 1/100 of a volt every 15 minutes or so.
This is a he said also, dang, hold up. This is a closed system?
Yeah, closed loop. I'll show you all the wires involved in this right now. There's a little bit more on the table than what the experiment is showing. I'm going to reset the meter just to make sure we're not being hoaxed by the meter. Yes, we are right on par. The meter is good. The meter has lots of juice in it. It is not failing right now. So virtually everything, not this. All this is in the circuit. Okay, so we got a SSG without gen mode. So there's no gen mode in this. We got a potentiometer, 10 turns,
100 ohm, or 1,000 ohms, my bad, it's 1,000 ohms, 10 turns. It's a 12 gauge drive, or 20 gauge drive, 730 turns, and a 30 gauge trigger, 730 turns. You got your input coming from here, 12 volt battery, and you got your output going into this cap bank down here in the corner. Let me readjust. I'm just trying to show that to you. There's the cap bank.
Is the turning rotor the one that generates the charge?
Well, I think the battery generates the charge that's being used here. This amplifies the charge. I'm not even sure the wheel has much of a part to play in all this right now. Look at how slow it's going. I don't know. I'm going to try spinning it again. I'm feeling the coil to see if there's a pulse going through it. I feel a little bit, not much though.
Won't the wheel just be wasting the energy? Question mark.
It's not. I don't know how to answer that. It's not wasting the energy, and I know what you're talking about. You're talking about oscillating coils. That's not what we're doing here. We're running pulse motors here. I have a few good oscillating coils over there on the other table.
Josh is in the house.
What's up, Josh?
He says, I see.
But yeah, definitely. This, I think that's what's actually happening here is that the coil is oscillating through the circuit, which may mean the transistor is blown, which is totally possible, but it still shouldn't be like going up. It should be going down, the battery supply, with a shorted out transistor. We'll see what happens. It did go from 1209 to 1210 on camera though, so. And that was its third increase. Let's see what happens. And even when you short, you can only short enough the amount of energy to your potential. As soon as you reach your potential, then you have a big fire. As soon as you decide to try and exceed that potential through shorting, it'll happen fast. But you get that maximum potential like that when you short. You get it like that, like boom, and it's right there and it's usable. And when it was like when the coil would like jerk back and forth, there was a short going on there, which may turn it into a permanent magnet all the time. Like a permanent magnet instead of an electromagnet which pulses. A permanent magnet which is always on.
Yeah, he said, hope you back a little bit, hope it goes up.
Yeah, me too. Thank you.
12 on 1. Plus.
But yeah, You know, it's hard for me to like explain what I know about it. I know pulsing energy is really important for stability.
Can I go to my car?
Yeah.
My phone here. Okay.
Is it going up or down? I don't know.
The boss says you need a cheap $15 transistor tester. Test each transistor before you put it on the circuit, just so you know each transistor value. Their values change over time.
I got you. Yeah, that would be a good idea, boss, to be able to keep an eye on all that stuff because, you know, if it shorts through the circuit, man, that's definitely an opportunity for the circuit to go bad. And when that base fuses, that's a short. That means that's on all the time. And yeah, I don't think that's happening with this particular transistor, but I do need to get one of those testers. Yeah, I don't know. What do you think we're at now for waiting on this?
20 minutes.
I don't know. Maybe I'll put a fresh transistor in there and see if it changes up anything. It's worth it to me to test that out. Okay, so we'll unplug the power. And if we unplug the power and that goes up, that means it was running. Maybe not. Haha. Alright. Probably not. So we're going to switch this out. Probably all that playing around with the double circuit that may have fried both the transistors. I got some of those MLJ ones coming in the mail. Right now we've got 2SC something 200 or something like that. These aren't too terrible, but they are pretty flimsy. 2SC 500 or something like that. Like the legs are pretty like breakable. Anyway, I don't put that much high voltage through these, so they don't really feel it unless there's a short, and then they feel it. They feel it really bad. I've had like the face pop off of one of these things with a spark. And if there's no face, so it just kind of blew right through the casing. All right. I'm thinking about setting up like a side circuit and then having like a booster, just in case it does have to do with speed, because that's a brand new transistor. Anyway, yeah, I was just thinking about maybe hooking this coil up like right here, and then just having it be on to increase the speed. Using the power supply, of course, to turn it on. It's an 18 gauge, so it'll be interesting. Just like that. Boom. Right now, I do believe there, and since there's no like definite, is the wheel being used for the charging, but since there is a lens effect, I'll move that out.
$1,500.
Nice. It'll slow it down. Let me look at our clock. Nice.
You saw that one?
Yeah, I don't know if that's true. I mean, as soon as you take the power out, you have to compensate for that power every time. It doesn't matter what's going on. As soon as you remove the spark, you have to compensate for that spark. And if you're already compensating and then some, you don't understand, man. All that is fine and dandy, but you have to leave the battery in the equation. You can't, like, this isn't sculpting, really, and I'm planning on building a magnetic sculpture, where, you know, you start with a big block, and you take stuff away until it looks like what it's supposed to look like. That's sculpting. You take parts away. This isn't sculpting. You can't take this away. You can't remove this. I'm telling you, as soon as you, even if you're going like 20 times faster than the amount that it takes to compensate for this, as soon as you take this away, all that math changes. All of it does. So you take this away in your math. Go ahead and do that. You take this away from your math and it's a totally different equation. Totally different. Because it starts in a different place then. It doesn't start at your spark anymore. It starts in front of your spark. And then it doesn't make sense at all and it'll fall apart. It's the reverse engineering like philosophy that you start from the beginning. That's where the beginning is, the start. Those two words are synonymous. Okay? If you start from the end, which a lot of engineers and sculptors, they do that. They start at the end. If you start at the end, it's going to look like it's going to work every time because you're not paying attention to the beginning. That's just my opinion. Until somebody can like show me that, until there's some huge conspiracy in modern times, I'm not talking about the ancient conspiracies, I'm talking about modern day conspiracies. 80s is ancient times.
80.
I'm talking modern day within a year or two. when a new conspiracy pops up. You know what I'm saying? The next one, the new thing. Not that, this, you know, people have suffered for doing this. That's insane. That's insane. That's crazy. To make people suffer for experimentation. That's crazy. I don't like that. And I'm talking about, you know, why? I don't understand. Maybe it was the mentality behind coming up with it in the first place, which, you know, made all that possible. But, you know, I don't know, man. I just,
Is that some,
yeah.
a meter?
Oh, no. Probably still at 210. 211! 1211, baby. Oh. Closed loop system. I'm pretty sure there's some oscillation going on right now along with this coil. And I'm pretty sure it's due to some enamel that has been melted inside of this coil. Because it's been so hot sometimes. I've had it for a few years now, like a year. I've used it in so many experiments. This one, and I'm sure that new big one is going to be a big thing in the future. So with the fresh transistor on, we are still moving. Uh-oh, I played with the resistance and look what happened. It touched. Wow, I know what I need to do. I need to take the pot out for now. I need to get the right connectors for the pot, because the pot, the clips that I have on it right now, they're too close together and they move. So I'm going to put some regular resistance on here for now. This will probably screw it all up, but we'll see what happens. It's already screwed up, so I'm not worried about it. Alright, so how we're going to do this is we're going to take this. Yeah, I don't have any more, and this one isn't working right. Now watch it run all pristine and everything and all fast. Whoa. Okay. So it's not going to let me not use the pot. Look at this. That neon bulb went on all the way. Huh. So maybe 460? Let's try that. Yeah, let's try 460. So we'll double it up because it obviously wasn't enough resistance. And then if that doesn't work, we'll do 460 plus 230. And if that doesn't work, I have a third one. Yep, that's not working. Huh. It doesn't make sense because it's a 1,000 ohm pot. Now, I have no idea if this is going to work, but I'm doubling the length of the strand and changing the gauge. All right. We're gonna leave that strand that on there. Huh. But I guess we're putting the pot back in. I don't understand this. This is ridiculous, is what it is. How 690 ohms and the light's still going on? Give me a break. Alright, so the pot is now This is, I mean, it's all because I'm trying to do it on the same battery. Man, okay, this sucks. The pot has become undone. Oh, good. There we go, this should work now. Yeah, man, these things are ridiculously small, and they have their own special little clips, and I hate it. So tiny, man. I'm a big person, man. These tiny things, I don't like them. Now the SSG light is on. I don't know. The wheel's moving though.
What's the meter say?
12.05. We're not there yet. We're not doing the meter right now. I'm just trying to get it all, the light off and everything.
Alright, man, like 10 more minutes.
Yeah, no, we might not get this right now. So, yeah, 10 more minutes at the most. But it's moving now. Alright, I'm moving the wheel in the wrong, the light's off.
Nice work.
I don't know how many turns that is in there, but I think it's like, 6 or 7 turns in, so like 700 ohms of resistance. But this is different. This is way different than what we were just doing because the wheel's moving now. And I do think that is an energy seep. But there we go. I'd say that is it. And we've leveled off at about 12.03. The resistance kind of where I want it. The wheel is spinning now, so that is awesome. But we're going to have to let you go right now. We'll come back to this. I do like doing this quite often. And we'll check you later. This is Papa Bale signing off. Peace out. Bye now.